This is section 6.6 on improper integrals, WebWork question number 14. It says for each of the improper integrals, decide if they converge or diverge by either calculating the integral directly or by using a comparison. For each comparison, be sure that you provide a good comparison integral for which the integrand is either larger or smaller, as appropriate, than the integrand of the integral that you are investigating. Okay, so let's look at these. First of all, why is this one an improper integral? Well, infinity is not in there, plus or minus infinity, but the problem is 5. If I plugged in a t equals 5 here, I'd have a 0 in the denominator. So this is an improper integral because this function is undefined at 5. There's a vertical asymptote at 5. It's defined everywhere to the right of 5, but not at 5. So what I'm going to do is I'm going to rewrite this to be the limit as a approaches 5. Now I got to figure out, is that coming from the right or from the left? Well, everything is to the right of 5. I'm not coming from the left. 9 is to the right of 5. So I'm going to let this a go from the right, and I'll have the integral from a to 9 of this function, which is, I'll just leave the 6 there, and I have t minus 5 to the 1/2 power dt, to the negative 1/2 power. 1/2 power is a square root, and it's on the bottom, so that's why there's that negative right there. Okay, this is something I know how to integrate. I can do a u substitution with u equals t minus 5, du is dt. Everything works out just fine. So this is the limit as a approaches 5 from the right of, if I integrate this, the 6 is still there. I'm going to take this thing, I'm going to raise it to the 1/2 power, t minus 5 to the 1/2 power. I'm going to have to divide by 1/2, which is the same as multiplying by 2. And I'm going to evaluate this from a to 9. Now if you want to write out that u substitution, you can, but you might be to the point now where doing a simple u substitution where u equals t minus 5 and du equals dt, you can do that in your head. But if you want to write out that u substitution, you'll get the same thing. Okay, finally I've got to plug in the 9 and the a, so this would be the limit as a approaches 5 from the right. Let's see, I've got a 12 times, if I plug in a 9, I'll have 4 to the 1/2. If I plug in an a, I'll have an a minus 5 to the 1/2. Now, what's nice about this is if I let a go to 5 from the right or the left, I have the square root of 0, which is 0. And that's not undefined. That's not going to plus or minus infinity. This is just going to 0. So what I end up having is 12 times the square root of 4, which is exactly 24. Now in this one, what they really want to know is, does it converge or diverge? This one definitely converges. And we could find that integral directly. Part B is another improper integral. Let me draw a line so we don't confuse these. Part B is another improper integral. The reason it's improper is that if I plug in a negative 5 into this, then I'll get something that looks like a 0 in the denominator. If I plug in a 4, that's totally okay. Anything to the right of negative 5 is okay, but the negative 5 is the problem. So I'm going to do the same type of setup I did here. I'm going to say that this equals the limit, as long as it exists, the limit as a approaches negative 5 from the right, because I care about to the right of negative 5, between 4 and negative 5, that's to the right of negative 5, of the integral from a to 4 of, let's see, this is really t plus 5 to the negative 2 dt. And again, that's an easy integral to do. I could do a u substitution where u equals t plus 5, but we're probably at the point now where we can do that without writing out the whole u substitution. So if I integrate this, it's the same as u to the negative 2, which would be u to the negative 1. So that t plus 5 to the negative 1 divided by negative 1. Dividing by negative 1 is the same as multiplying by negative 1. And then I'm going to evaluate from t equals a to t equals 4. Okay, once again, I can plug these in. let's see what I get. This would be the limit as a approaches 5. I should still say from the right here. The limit as a approaches 5. I'll take that -1 out, so maybe I'll put the negative out here. Oh man, sorry about that. There we go. So I've got that -1 out there. And then let's see what I have. This, if I plug in a 4, I get 1 over 4 plus 5, minus, if I plug in an a, I get 1 over a plus 5. T plus 5 to the -1 is the same as 1 over t plus 5. There's me plugging in a t equals 4, and there's me plugging in a t equals a. Now this is just 1/9, so that's a constant. But if I plug in a 5 from the right, I'm sorry, a -5, keep on making typos, a -5 from the right, this is going to be a 0 here. So if I plug in a -5 from the right, I'm going to get 1 over something that's going to 0. Now, this guy right here, if I plug in a -5, to the right of -5 would be like -4.9. This would be a negative number, and I'm going to subtract a negative number. This whole thing here is going to go to positive infinity, but I'm subtracting it and then multiplying by negative, so this whole limit is going to go to positive infinity. Now this is a divergent limit because it's not going to some constant. So this is an example of one of these improper integrals that diverges. Okay. For the next 3 examples, you can see we've got limits of infinity, limits of integration that have infinity in them. Alright, so we should think about a way to do these. We're probably going to do a comparison. So one of the things we should be aware of, and maybe I'll get another piece of paper to write this fact down, is that if I have the integral from 1 or 5 or any constant to infinity of 1 over x to the p power dx, we learned that this converges if p is any number bigger than 1, and it diverges if p is any number less than or equal to 1. So if p is 1, it diverges. If p is 2, it converges. So any constant, whether it be 1 or in this example 6 or 5 or 5, those are the rules. This is sometimes called the p-value test, and this ends up becoming really important in the next semester of calculus. Okay, so let's use that rule to figure out what's going on here. This looks a lot like this integral, the integral from 6 to infinity of 1 over the square root of theta cubed d theta. The only difference is that this one is just a little bit bigger on the denominator. Well, if the denominator is a little bit bigger, this integrand is a little bit bigger. Well, this falls into one of those categories because this is the integral from 6 to infinity of theta, 1 over theta to the 3/2 power, d theta. So I think about 3/2. I think about that rule we just mentioned right here, that if p is bigger than 1, it converges. If it's less than or 1, it diverges. Well, our p in this case is 3/2. That's definitely bigger than 1. So this one converges. Well, just because this integral converges, we've got to think about, does that imply that this one converges? And sure enough, it does. If my integral is something less than something that converges, then it must also converge. If it was bigger than something that converges, that doesn't tell me much. But if it's less than something that converges, this one must also converge. Okay, maybe we can do something similar with the next ones. Let's see. This one right here. I see infinity there, and I see an e to the z plus 5 to the z. And I don't really want to try to integrate that, so I'd like to compare it to something that I can integrate. Let's compare it to the integral from 5 to infinity of 1 over e to the z dz. I think that's something I'll be able to integrate. When I do that comparison, let's see what happens. Which one is bigger? Well, again, this denominator is bigger, so this overall integrand is bigger, so the inequality sign goes that way. Well, this is the same as, and now I'm going to do one of these improper integrals, the limit as b approaches infinity of the integral from 5 to b of e to the negative z dz. This is one of our easiest integrals. This is the limit as b approaches infinity. The integral of e to the z is e to the z, but the integral of e to the negative z is e to the negative z. I just have to remember to divide by -1 or multiply by -1. And then I'm going to evaluate this from b to 5. Now this doesn't fall right into one of my p-value tests, the little trick from before, but I bet I can still figure this out. This is going to be equal to the limit as b approaches infinity of, I'll take that -1 out, and this is 1 over e to the z. So if I plug in a b, it's 1 over e to the b minus 1 over e to the 5. Now once I've done that, I really care not what this number is, what this limit is, but whether it's plus or minus infinity or a constant. Well, as b approaches infinity, e to the b gets enormous, so this thing goes to 0. So this limit does equal a number, and the number it equals is negative that. It's 1 over e to the 5th. I don't really care what that is, because I wasn't asked this integral, I was asked this integral. Well, this one definitely converges, and this integral is less than something that converges, so it must also converge. Okay, the last one. Again, I have infinity here, so I'm thinking about perhaps using this p-value test, whether p is bigger than 1 or less than or equal to 1. Let's see. I can compare this, and this looks almost like the integral of 4 over alpha d alpha. Now, which one is bigger? This integral, sine theta, could be as much as 1, but it could be as little as -1. So I want to compare that in a better way. That 4 doesn't look great. In fact, I know that 4 plus sine alpha is sandwiched somewhere between 4 plus a -1, which would be 3, that's the smallest it could be, or 4 plus a +1, which is a 5. So maybe that 4 over alpha isn't what I want. Maybe I want to use the 3 or the 5. Now, you could kind of look either way, whether I use the 3 or the 5, what this integral is going to do. I'm going to have an x to the 1 power, an alpha to the 1 power. I think this integral is going to diverge. Whether I put a 3 or a 5 here doesn't matter. So which way do I want to go? Do I want this one to be smaller than this one, or do I want it to be bigger than this one? I want this one to be smaller. I want this to be bigger than an integral that's going to diverge. So what I want to do is I want to go this direction, because I want to prove that this one diverges. So what number should I use here? Should I use a 5 or a 3? Well, if I want the smaller one, 3 is smaller. So 3 is going to work. This integral definitely diverges because I have alpha to the 1 power, so it diverges. This integral is bigger than something that diverges, so it diverges as well. Okay, I know there was a lot going on there. Some of these integrals we could calculate directly, plug in the limits. Some of them we had to make kind of clever comparisons.